Benthic macroinvertebrates can be loosely defined as just organisms without a backbone that are large enough to see unaided. All of the slimy, crunchy things that are under our feet would classify. There's a lot of mollusks, there's a lot of freshwater snails, clams, mussels, crustaceans, beetles that can be both aquatic and fly. Within that are all of the aquatic insects. We're collecting them in their aquatic life phase. We're not seeing it flying around. We're seeing the nymph that gets its oxygen from the water. Benthic macroinvertebrates tell us what's been happening in that system over some period of time. You can then screen for things, and the types of communities that develop with some types of pollution can even tell you, hey, I should be looking for this. If those taxa are composed of individuals that are really tolerant to low oxygen levels, then we know we could be looking at either nutrient loading or possibly a sewage spill. Organisms like mayflies and stoneflies and caddisflies are able to obtain enough oxygen with all the water flowing over them, because as they consume dissolved oxygen gas in the water around their bodies, it's constantly replaced by being brushed over. Those organisms tend to have higher metabolisms and be moving around more. As a group, they tend to be less tolerant to pollution or habitat change compared to other organisms, as opposed to something like a freshwater mussel or a clam. If dissolved oxygen goes down and you have that low metabolism, you can just kind of close up, wait for things to be better. Diatoms are these small algae-like organisms, but they differ from algae in that they are contained within a hardened case called a frustule. It's kind of like glass, which is silica-based, and so they give us a strong signal similar to the benthic macroinvertebrates, but for different stressors. One thing they will respond to for sure is how much silt or sediment is being deposited, and that can be caused by erosion. Types of individuals, their numbers, and their relative proportions to one another goes into a score that becomes what we call the benthic subindex score. We can say this is high and we think there's a spill or something happening. So some things have an immediate response. And then on top of that, we can compare spatially and say, is the ecology of Barton Creek better than, the same as, or worse than the ecology of a segment on Waller Creek? And by ranking those watersheds, we can then say, here's where we need to allocate most of our efforts. We know increased impervious cover changes the hydrology of streams, and we do see that reflected in those communities. Places that have not been overdeveloped or just covered in impervious cover have not only better ecological function, they seem to have more utility for the people who call this place home. Barton Springs Pool is still considered the crown jewel of the park system. The public at large really seem to care. It's what makes it a very livable place.